All right, Algebra 2, welcome back, guys. We are in Section 3 today. So Chapter 3, Section 3, where we are solving systems of linear inequalities. All right, so basically, we're going to be doing graphing of inequalities, where you're going to have a system, meaning 2, potentially 3, or even potentially 4 inequalities that could all be graphed on the exact same coordinate plane. You're going to be doing shading. You got to pay close attention to that inequality where we may have a dashed line, we may have a solid line. All of that is important. Okay, so first thing is remember everything that we've already done with graphing inequalities. All right, you got to remember shading because you're going to have multiple inequalities. I know it says graphing 2 inequalities on the same coordinate plane. You may have 3, you may even have 4, like I said. Okay, so don't forget when you're graphing inequalities, for starters, always change the inequality so that it is y and then everything else. So it's basically the slope-intercept format, okay? And then if you take out that equal sign, you're just going to substitute in an inequality. That's what the book's going to give you. Okay, if it says greater than, then you're going to shade above and it's dashed. If it says greater than or equal to, you shade above and it's solid. All right, if it's less than, you shade below and it's dashed. But if it's less than or equal to, then you shade below and it's a solid line. Okay, now it would be easiest, as it says, to get every equation in slope-intercept. That's exactly what you should do. Not only is it easier to graph this without the calculator, but it's insanely easy then to graph it with the calculator if you have it into that slope-intercept format. Okay, now the calculator could honestly do all of this. All right, so if you have it in slope-intercept format, you can plug it into y equals, but after you have the equation in, you're then going to move to the left a couple times, and you can change the graph to then shade. All right, and I can show you guys how to do this in class or on a Zoom, and that way we are basically able to do nearly everything on the calculator. But that calculator breaks, you forget how to do it, that's okay, because we could always still do this without the calculator, and it's not that hard. Okay, so let's jump into it. Here we go, first example problem. All right, right off the bat, it is not set up as y equals. So that's the first step, is change this into the y equals format. All right, so the first equation we have here, x minus 3y less than 6. All right, so actually what I'm going to do is I am now going to take the 6 and I'm going to move it over here. And I'm going to take this negative 3y and I'm going to move it over here. All right, the reason why I'm going to do that is because of that negative sign in front of the 3. If I can get that to be a positive, then I don't have to worry about dividing and flipping. Okay, but what you should also notice, though, is because you've now moved the y, it's going to change the orientation of that inequality. Here's what I'm talking about. So we now have it set up as x minus 6. We're still using that symbol the same way, but notice the 3y is on the other side. Okay, so everything will then be divided by 3. And that's now going to create the new equation here of 1/3 x minus 2 less than y. I know we kind of just barely got that in there. So let's go ahead and take that. Let's rewrite it down here. All right, we'll put it in the right order, the whole y equals mx plus b format. So it's y, and then we have 1/3 x minus 2. And I don't want you to think that, oh, he flipped the inequality, it's incorrect. But look at the way that it's written in the upper left there. You see how you have 1/3 x minus 2 is less than y. You guys remember in elementary school, it's like the alligator eating the bigger thing. The alligator's eating the y. We'll look down at the other equation. The alligator's still eating the y, you know? All right, just use that nice same analogy I'm sure you guys got used to in elementary school. All right. Now, in the other second equation, we're going to take that 2x and bring it to the other side. All right, because notice the y has a coefficient of 1 and it's a positive, so don't move the y. It's already in a good position. So now we are looking at y greater than negative 2x plus 1.5. Okay, so everything looks good right there. Now all we have to do here is graph. Okay, so we're going to do one in blue, one in red, just as it's already set up. So let's do the blue equation first. Slope-intercept format, we would use the y-intercept. It says -2, so we go down 2. All right, there's a dot. Then the slope is 1/3. That is a rise of 1 and a run of 3. So go up 1, then 1, 2, 3. So we are right there. Then what we are looking at is, let's see, we have a dash line. All right, dash line. So let's go with dash line. Okay, and it says y is greater than. So we will be shading up here. Okay, all right, now let's do the red equation. So we go up 1.5. We are right there at 1.5. Then as a slope of -2, don't forget that there always is a 1 underneath it. So we would go down 1, down 2, then to the right 1. So we are right about there. And again, this is just greater than. We don't have the or equal to, so it's dashed, right? So let's go with a dashed line. I understand that definitely does not look like it went through the points, but all right, written by hand, doing the best we can here. And we are shading where y is greater. And where will y be greater? It's going to be greater up here. Now what we have to do is we have to show the overlapping portion. So I'm going to do the overlap in green so that you could see everything that is overlapping is just in this area here, right there, okay? So you have the red equation, you have the blue equation, look at their shading, and the green is the overlap of the two. And when you graph these on your homework, I have to see darkened shading where they overlap. Okay, let's do the next one. Right, number 2, here we go. Y is less than or equal to 4. That's simple. That's already set up, so that's nice. So let's do the other equation. The 2x needs to be brought over. So when we do that, we have y is less than a negative 2x plus 1. The 1 didn't move. It's positive, so that's why we put plus 1. All right, so we're going to do this equation in blue. This, of course, is going to be done in red, and we'll show the overlap in green. So let's start with blue, nice and easy. Y is less than 4, so go up 4. 1, 2, 3, 4. We're going to put a dot right there. It does say or equal to, so that's going to make a solid line. And it says y is less than, so we shade below the line down there. All right, next part, let's do the y is less than negative 2x plus 1. So we go up 1, put our dot right there. A slope of -2, don't forget that it's really over 1. So from there we go down 1, down 2, but then to the right 1 time. So we are right there. Then it does not say or equal to. So we are looking at a dash line here, right? Let's go that way. Let's go this way. And I kind of recommend that you guys do cross the two graphs if possible, just so you get clearly defined regions in your graph, okay? And this says y is less than, so y is decreasing down here with the graph. And let's look at where they will actually be overlapping. they will be overlapping in this zone right here. But notice right there, we don't go any higher. Okay, so you see the blue, the red, the green is the overlap dark shaded zone. Okay, okay. Let's move in. Last example problem. All right, here we go. This example problem, I know it doesn't show it in the directions, but in the book, if they give you 3 inequalities, they're going to want you to put all 3 on the same coordinate plane. It will create a triangle, but you have to try and figure out what type of triangle. All right, a right triangle, isosceles, equilateral, all those terms that you guys did last year in geometry. All right, so first one, let's do this one in blue. Let's do this one in red. Let's do this one in yellow. And again, green will be that triple shading overlap. Okay, so back to blue. X is less than or equal to 6. Just go to where X is 6. 1, 2, 3, 4, 5, 6. We're all the way over to the right there. And it does say or equal to, so it is a solid line. And X is less than. So we are shading on the X decreasing, going to the left. Okay, let's go to red here. Already set up as Y equals for all these, which is great. So now we have the +1, so that's up 1. The slope is 1 over 2, so that is up 1 over 2. We are now right there. It does also say or equal to, so it's another solid line. All right, and don't forget to cross the other line again if you can. And it says Y is less than. So we have this down here. All right, now we move on to our final equation. +4 means go up 4. 1, 2, 3, 1, 2, 3, 4. All right, there's my Y equals. The -2, don't forget over 1. So 1, 2 down, but then to the right 1 time means we are right there. Okay, and it again does say or equal to. So we are drawing a solid line right there, right there. Okay, and this says greater than. So we have this whole region up here. Now what I want you to see, what we will darken is the triangle that is created. And in green, you can see we have a triangle right here. All right, here's the exact region that is completely bound by all 3 of those inequalities with the shading overlapped. That is the region, okay? And I'm going to probably guess that that might be an isosceles triangle. All right, so that's how you do problems just like that. All right, guys, that's all I got for you. See you in the next one.